Hello friends, welcome back to Code with Roy. Today we'll be learning about Retrieval Augmented Generation or RAG. This is a very useful concept while we are trying to build any AI agent or agentic AI. Both both the places without RAG almost it's not possible. So today we'll be learning about this concept. We'll be learning about vector database and how we use it, and in our future video we'll be programmatically use this retrieval augmented generation. So without wasting any more time, let's start. What we'll be learning in today's video is what is RAG workflow overview, what is a vector database, how vector database work, what is embeddings, embedding examples in action, RAG versus traditional search, use cases of RAG plus vector DB. So all these are interrelated to each other. Once you'll be learning, you will understand it completely. So stay till end of the video. Otherwise, you won't be able to complete this whole RAG learning process. So introduction to RAG. As you already know, the name is Retrieval Augmented Generation. It's an AI technique that combines two powerful approaches. What are the two powerful approaches? One is retrieval. So retrieval is, instead of relying on what a language model like GPT was trained on, RAG retrieves relevant information from an external knowledge source, like a database, document, or a vector store. This ensures that AI has up-to-date and accurate facts. So to explain it little more details, normally if we ask a question or if we send a prompt to ChatGPT or like any other AI models or LLMs, it gives us some informations what it was trained on. But if we need very specific response, so say like we are developing an application for our company, right? And people are uh, doing chat, means we are generating a chatbot, right? And then people are asking very specific question to our company, and then normal AI or chat GPT won't able to provide very specific answers for those questions. So that time we have to feed or add our external knowledge base before we call chat GPT to provide a proper response or accurate response. So this is that retrieval process. So we are now learned about R of this RAG. So retrieval is nothing but we are feeding or we are adding one external knowledge base. So that is where it will retrieve the knowledge. Now, second important thing is generation. So what is this generation? Once the relevant information is retrieved, the AI model uses it to generate a natural language response, making the answer more reliable, context aware, and grounded in real data. So now once we retrieve the data, we need to generate a overall response, right? That is the generation. So then we pass that retrieved data or the knowledge base we acquired, we pass it to the AI model or LLM, and then we generate a more detailed answer regarding that question someone has asked, and that process is called the generation. Now, what is augmented? So we learn about retrieval and generation, but what about augmented? So augmented is retrieval. Augmented in retrieval augmented generation means that the generation process of the LLM is enhanced. So augmented is nothing but it means enhanced. So we are feeding some extra knowledge to the LLM to generate an enhanced response. So this is that augmented, that we are basically adding an enhanced data. So that's enhanced is augmented here. So now we know this overall process. We are first retrieving and then we are generating an overall response, but that response is enhanced or augmented. So that's how it is retrieval augmented generation. Example, say, what if we ask a question to normal LLM, right? What's the latest Apple iPhone model? It probably won't have the latest information and it can provide some guess answer, right? But if we want to make ensure that LLM always will give accurate answer, then we can feed this data that last iPhone was uh, means the latest iPhone is iPhone 16 Pro and was released in September 2024. Then using this RAG, LLM will always give accurate answer that latest iPhone is iPhone 16 Pro, which was released on September 2024. So I hope now you understood the overall idea about RAG, and we'll move to see how it works. So this is the workflow overview. Steps in RAG. So first step is user query. So user queries means user asks some query, say what is the latest iPhone, that's the query. So what it does, this overall process, it converts into vector embedding. We'll be learning in future slides what is vector embedding. For this slide, just understand that uh, that whatever the text query someone did, this RAG actually converts it into some vector embedding. We'll be learning about what is vector and what is embedding in soon. Then retrieve information. So after that, what it does, it retrieves some information. If you see here, someone has asked a question and this LLM smart search, this is actually converting this question into vector embedding and then pass that vector embedding as a query to this data and got the relevant information, that is the retrieval. And then combine retrieve data plus query, and then it's combine this retrieve data plus whatever query someone has asked, those two, and then it passed that question LLM question plus relevant information, the relevant data to a LLM. This is an LLM, this brain sign is a LLM, and then LLM is giving an enriched answer to the member. So generate final answer with LLM. So this is the process actually. We'll be uh, do a little deep dive into this retrieval augmented generation. We'll break this section, this second section. It's not as simple as this one. So we'll be segregate into small pieces and understand how this works. This retrieval information or information retrieval process. Okay. So here we are seeing this overall picture, how this exactly works. So this dotted line section, if you see on the top, this dotted line section is very essential, and let's understand this process. So if we are creating an AI agent, we need to create a knowledge base. So how to create a knowledge base? So this is that process explaining how we create our knowledge base. So first, we ingest our information. So it may be a document, it may be a audio, it may be a video, it may be anything, right? PDF file, database. So we pass our knowledge base. Here it's showing as documents. So this information can be indexed. Now what this process will do, it's chunk these documents. So say these documents has 10,000 lines, right? I'm just explaining one document has 10,000 lines. So it might can take out those 10,000 lines separately, or maybe a small piece of each line as a chunk, and it creates a chunk. Okay, so for our simplicity, let's understand a document with 10,000 lines. This chunking has created 10,000 chunks, each line as a chunks. Then there will be a embedding model. We'll be learning about embedding model, but what it does, this embedding model actually create a vector out of these chunks. So that's the work of embedding model. So this vector is nothing but a numerical representation of a text. So say if I say that uh, hotel rent is $250 per night, then it will create a embedding and it will convert that hotel price is $250 per night into some numerical representations and will store here, because machine doesn't understand what is hotel rent at night is $250. Machine doesn't understand English, right? So we are converting that English into some numerical numbers and convert it into vector space. So this is where we are storing, and then we are indexing it to vector store. So we have a vector store, or it can be any vector store database where we are passing those numerical numbers and storing it. And while storing, it will store that numerical number and always have a link to that text, whatever we have sent, so that they will understand, okay, this text is represented by this number. So this is overall uh, how we feed our data or knowledge base to a vector store or embedding system. So hope this much is clear now. The next process is when user is querying about something. So say user is asking to that chat model that what is the per night cost of the hotel. So what will happen? This user has asked the query. This query is also will go through an embedding model so that they can convert that question or the query into vector, right? Because on vector they cannot search with a text, because this is a vector database, right? So we have to convert our question as well into vector. So here we are converting the question that what is the cost of per night rent of this hotel, we are converting into vector, and then using that vector we are searching in this vector store. So once it's searching, it's got a relevant answer, and then we are got that answer here. So we have retrieved. So this is that retrieval process. The question came, we use embedding model, convert it into vector, search in the vector store, and then got a relevant answer. So we got the relevant answer, and then we always had the query which member asked. So now here in augment section we have two things. One is that original query, and then the relevant answer we retrieved from vector store. Now we have both, and then these two things together we are passing to LLM, means large language model. It's maybe ChatGPT, it's maybe same any other LLM, and then it generates a very knowledgeable answer with very accurate descriptions, and it's sending it back to sending the response back to the user. So this is the overall process. I hope you now completely understood what is RAG, means how it works rather. Let's go and check in next slide. In reality, what are the components we use for each or to replace each of these components. So this is the components we use. So first of all, to create that vector data store, we pass our business documents. It's maybe text file, it's maybe PDF, it may be database, it may be images, or it may be audio file, anything. And then this one, this particular thing, right, this embedding model and these chunks, this embedding model is uh this is the chunks thing, means Azure blob storage. So it's created all the chunks and vectorized documents. So first we pass those documents, it created the chunks, and then it's vectorized the documents using this embedding model. So this is the real life embedding model example. Embedding AI model, text embedding 3 small. So this is a chat GPT embedding model. So it is now creating the vector and loads the vector into index. So it is creating the vector and loading the vector into index. Now someone is questioning a member is this is the start of the process, means the implementation of the AI agent. User has asked a question. Again, we are using that same embedding model to create the vector out of the question. So the query is getting vectorized inside this embedding model, and then we are searching in that index or the vector store, and we are retrieving. So this is a retrieval process. We are retrieving, and then now here we have augmented section. This is same as this one, where we have both retrieval and retrieval knowledge as well as the user question. So we have both. Now we are passing it to the LLM. This is the LLM Azure GPT-4 model, and then we are generating the proper or well crafted LLM response related to business data. So now finally we are passing that response to user. I hope now it's all clear about this concept. We'll move to the next slide. What is a vector database? Now, what is a vector database? So, definition: a vector database is a special kind of database built to store and search vector embedding efficiently. So, it's not like a relational database like Oracle. It is a vector database where our text or informations are stored as a vector. Why needed? Normal database cannot handle similarity search well. So what happens in normal database? It will search exact search like select star from this, where exact search it puts where dog name is equal to X or where animal is equal to dog, but it cannot do similarity search. So that's how to avail the similarity search we need to do vector. So vector allows semantic search by meaning or just keyword. Sorry, not just keyword. So it's basically search by meaning. So this is why we need vector search. Popular vector DBs. So these are all the popular vector DBs like Pinecone, Waviate, Qdrant, Milvus, Pace, Chroma. So these are all vector databases. Now, one such example of vector search is, say we are querying dog picture. Keyword DB means all our other databases, right? It will do keyword search. So it will match only dog text. So it will give us only dogs. But in vector DB, it will do similarity search, and what it will do, it will find images of dogs even if labeled puppy. So puppy is similar to dogs, right? So it will even can search puppy using that vector DB search. So that's the difference. Now what is vector? A vector is just a list of numbers like this. So this is how a vector represents. It may be multidimensional. So here if you see, it's multidimensional. It can be one dimensional, two dimensional, three dimensional, and it can go to 1,000 dimensionals. We'll see that. So vector is just a list of numbers like this. In AI, vectors are used to represent the meaning of text, images, audio, or video. In AI, vectors are used to represent the meaning of text, images, audio, or video. Means any text, images, audio, or video can be stored in such numbers in vector database. These are created using embedding models, e.g. OpenAI, Hugging Face, etc. So these embedding models basically convert whatever text or image or audio, video we pass to this kind of number. So these are the embedding models does those. Example, cat is represented like this and dog may be represented like that. Similar thing. These two vectors are close together because cat and dogs are semantically related. So now vector database only know that this vector is similar to this vector. And if we ask that what is more relevant pet rather than cat, it can probably search in its database to see what is the closest match, and based on this vector, and it can figure out the dog. Okay, traditional databases like MySQL PostgreSQL, MongoDB are good for exact matches, e.g., where name is equal to Alice. But in AI, we need similarity search. Find me documents similar in meaning to this query. So these kind of searches only can possible with vector. This requires comparing vectors using cosine similarity, dot product, or Euclidean distances. A vector database is designed for this exact task. So that's what it is, right? It means we cannot do normal exact keyword search here because we need a similarity search, and that's why we need a vector. How vector databases work? Stores embeddings, which are vectors, along with metadata, that is original text, file name, tags, etc. Indexes vectors using specialized algorithms like HNSW, IVF, etc. For superfast search, perform similarity search to find the top k most relevant vectors for a query. So what it does, it first stores any text or any information in the form of vectors, and it's always keep a track with its metadata, that what is the original text and what is the file name and what was the information it's storing along with the vector. Second, it's index all its vectors so that during search it can respond super fast. Third is it does similarity search so that it can find the top k, means top most relevant vectors for any query. Example, how it works. So say user query is how to reset my Gmail password. If someone is asking this query, it has already everything stored in its database as a vector. So it's changing this query, how to reset my Gmail password, to this vector format. And then it has index database and it's search on that indexes, what its matches. So search in vector DB finds closest match based on these vectors. It finds closest match these two. Click on forgot password at login screen. Google will send a reset link to your recovery email. And then it's passed these two informations which it retrieves from the vector database, and it passes to the LLM and generates a natural answer. So hope you understood how vector database works. What are embedding? So when these are two very similar things but a little different, that embedding is the process through which we create the vector, and vector is the end product of the embedding. So what are embeddings? Definition is numerical vector representation of data, text, image, audio. So anything can be converted into vector using embeddings. So for that we need embedding models. Capture semantic meaning rather than exact words. Generated using embedding models. So these are this is one of the embedding model. So embeddings are generated using embedding model. So what we need one embedding model, and if we pass any of our text, image, audio, or any information to the embedding model, it will create a vector out of that text, image, or audio. Example, if we pass a sentence like I love pizza, it will create an vector like this. Sentences, pizza is my favorite food, it will again create similar embedding, similar vector through the embedding, and it will have a track that these two sentences are similar based on the vector similarities. Both are closed in vector space because they mean the same thing. So this is how these embedding things work. Query. What is machine learning? Embedding search returns. Machine learning is a subset of AI where systems learn patterns from data. It enables predictive models without explicit programming. So this kind of questions can be converted into vector and then can be done a similarity search and we can retrieve similar responses. How it helps: instead of keyword match, embeddings find conceptually related text. Different embedding models and their specifications. So these are the different embedding models we have now and their specifications. So let's go through this. OpenAI has this embedding model, OpenAI ADA002, and it has 1536 dimensions. It's a huge, means it can be very accurate because its dimensions are so huge. It can store data in vectors very means in more combination permutations it can do with its huge availability of the dimensions. So it can be very accurate. So if you see strengths: high accuracy, easy to use. Weakness: it's a paid API. Use case: RAG, semantic search. So we use this embedding model for RAG and semantic search. Similarity is BERT. This has 384 to 768 dimension dimensionality, means it can have this much dimension. It's open source, fast, slightly less accurate, and chatbots FAQ search. So we can easily use this SBERT uh, embedding model because this is an open source and this is quite enough, quite good. Means it has also lots of dimensions. Cohere Embed V3. This has 1024 dimensions. Multilingual, paid API, multilingual retrieval. Google use Gecko. This has 512 to 768 dimensions. Accurate, Google Cloud support, vendor lock-in, enterprise search, Google Apps. Clip, it has also 512 to 1024 dimensions. Text plus image embedding. So its strength is it can convert text as well as image into vector. And heavy model, multimodal search, text to image. So using this one we can do text to image searches. So this is all about embedding models. Now we'll be learning about RAG versus traditional searches. So retrieval augmented generation versus traditional searches, what are the differences? So says these are the features, these are traditional searches and these are RAG. So search method: for traditional search method is keyword search. You all know, right? We used to search till couple of years back, we used to always search with keywords. Now we are doing semantic search through RAG and with vector DB. So traditional search is keyword search, RAG is semantic search. Knowledge freshness: traditional search has limited knowledge freshness and RAG is always up to date. Context awareness, it's very low. Traditional search context awareness is very low because it is doing only exact search, and RAG context awareness is high because it do similarity search. Answer type: snippet, links. So traditional search basically gives us snippets or links because it does exact search, and RAG, it does full natural answer because after retrieval it also generates the final answer using LLM. So that's how it's full natural answer. Use cases of RAG plus vector DB. What are the use cases? Customer support. So in customer support without RAG, it's not at all possible to uh, convert it into AI agent, agentic customer support, because we always have to provide exact correct answer to the member. Otherwise, it won't work. So that's why to feed the knowledge base, we always need RAG and vector DB. So this is where we can use RAG and vector DB for customer support. Healthcare, similar. We need medical in knowledge for patient queries. Without, we cannot use generic knowledge there. So we need a specific knowledge. So that's why we need RAG and vector DB. Legal, obviously we cannot people won't be happy if we give generic knowledge, so we need to give exact. So wherever we need to provide exact knowledge, we need RAG and vector DB. E-commerce, obviously personalized product recommendation, we need that. Education, we cannot provide generic answer to a question, right? So we basically need to feed the textbooks as a vector DB, and using RAG we need to pull exact correct answer from the textbooks for any of user questions. So this is the end slide summary what we have learned today. So we learned RAG, we know now what is retrieval, what is LLM generation. We learned about vector DB, we learned about memory, knowledge base layer of knowledge base layer for RAG. So RAG is that memory or knowledge base for sorry, vector DB is the memory or knowledge base layer for RAG. Embeddings is the process through which we convert text to vector, or you can rather convert anything like images as well as audio, video to a vector. So that process is called embedding. And for that we need embedding models. Together they power smarter, more factual AI applications, of course. Final thought, LLMs are powerful brains, but with RAG plus vector DB, we give them memory and knowledge access. Of course, we do. So this is it for today. If you like this video and if you learned anything through my video, please support me. Please subscribe my channel, like this video, and share this video with your friends so I can get motivated and keep creating new videos for you. Thank you so much. Have a nice day ahead.